Hey you guys, this video is going to be on simplifying radicals. So basically all we're trying to do here is break these down so that they are written in simplest form. So any perfect square that is in 8 or that is in 24, we want to take it out. All right. So the method that I'm going to show you right now is called the factor ladder. You don't have to do it this way. There's other ways to do it. So if this way just doesn't seem to make sense to you, make sure you just ask your teacher for a different method. And maybe that'll work better for you. All right, so the idea here is like the square root of 8, you can see is not a nice number. It's not a perfect square. So we're just going to try and simplify it and write it in perfect form without having it be a run-on decimal. So what you're going to do is you're going to take the number and you're just going to start to divide it by prime numbers. Now, prime numbers mean the only thing they're divisible by are 1 and itself. So, for example, 2, 3, 5, 7, 11, 13, so on and so forth, okay? Typically, you'll use these lower numbers unless you get a number that does, have an 11 or 13 that goes into it. All right, so I'm going to take 8, and I know 8 is divisible by 2. So 8 divided by 2 is 4, and now my goal is to keep dividing until I get down to 1. So 4 divided by 2 is 2, and 2 divided by 2 is 1, okay? So now that I'm at 1, I want to find pairs because when we're talking a square root means what two numbers multiply to be a number, okay? So like, for example, the square root of 4 is 2 because 2 times 2 is 4. So go through your list of numbers and circle any group of 2 that you find. So here, this is one group of 2, okay? So what this tells me is I could rewrite this as 2 times 2 is 4. So the square root of 4 times this square root of 2 that's left over. Now the square root of 4 is 2, and I can't do anything with that. So my final answer would be 2 square roots of 2. Okay? Now, to shortcut it, we don't really need to do this step. You can if you want to, but you don't have to. Any group of 2 is written as a number on the outside. Anything that's left over not in a group of 2 goes back under the radical. Okay? So final answer would be 2 square roots of 2. And then you can check to make sure that you're simplifying this correctly. So again, I'll type in the square root of 8, and then I'll type in 2 square roots of 2, and you can see that you get that same run-on decimal, so you did break it down correctly. Okay? All right, next example, same thing. So I'm going to take my number, and I'm going to divide it by prime numbers until I get down to 1. So I'm going to start with 2 again, just because that's what I thought of first. So 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3, and then 3 divided by 3 is 1, okay? So I'm going to look through here. I have 2 2's, so I'm going to circle those. All right, now again, this is like the square root of 4, which is 2. And then these don't have a pair, so I'm going to multiply them back together and then put them back underneath the radical. So 2 times 3 is 6. All right, so your radical simplified would be 2 square roots of 6. And then again, check your answer. So square root of 24 and then 2 square roots of 6. And you can see again that you get the same thing. All right. This works the same with cube roots as well. So if we take a look at a cube root example, let's do the cube root of 108. Okay, so the nice thing is it's the same process for every single problem, no matter what root you're taking. So I could be taking the 4th root, the 5th root, the 6th root. It doesn't matter. You still make your factor ladder and then look for your groupings of numbers. All right. So 108 divided by 2 is 54. 54 divided by 2 is 27. Now I can't divide 27 by 2, so I have to switch to a different prime number. 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. Now, the only difference here is that we're taking the cube root. So now instead of looking for groups of 2, like I did for the square root, I'm now looking for groups of 3. Okay? So I have a group of 2 here. I'm not going to circle that because, again, I'm talking the cube root. I do have a group of 3 3's. Okay? Now, this is the same idea as the last time. 3 times 3 times 3 is 27. So essentially what I'm doing here is the cube root of 27 times the cube root of 2 times 2, which is 4. Okay, 27 times 4 still equals 108. The cube root of 27 is 3. And then left over, I have the cube root of 4. But again, the shortcut of this is just any group of 3 terms goes to the outside as one number, and then anything remaining is multiplied back together and put back under the radical. Okay. I think the only other thing left to talk about is what happens when there are multiple groups of numbers. So let me come up with an example here. All right, so let's break down 72. So let's say I asked you to simplify the square root of 72, okay? So I'm going to do my factor ladder here quick. So 72 divided by 2 is 36. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. Okay, so I'm talking square root, so I'm looking for groups of 2. So here's a group of 2 2's. Here's a group of 2 3's. Okay, now if we think about how this would look, this would be the square root of 4. This is the square root of 2. And 3 times 3 is 9, so the square root of 9. Okay, so notice how everything is always being multiplied back together. So what do you do when you have multiple groupings? Well, the square root of 4 is 2. The square root of 9 is 3. Since all of these are being multiplied to get back to 72, any multiple groupings coming to the outside needs to be multiplied back together. Okay, so your final answer would be 6 square roots of 2. Okay, so if you have multiple groupings, again, each grouping goes to the outside and they're multiplied back together. So again, hopefully this helps. If you don't like this method of the factor ladder, there's many other ways to break down radicals. So again, just let your teacher know and they should be able to show you an alternate method.